So we are already done with the chapter. Let's see the numericals from chapter 2. Alright, let's start simple. Let's start with the first one. Question number 1. A body, when acted upon by a force of 20 kgf, gets displaced by 1 meter. So what's given here? Force. How much is the force? 20 kgf. Alright, that's another unit of force, kgf. Gets displaced by 1 meter. That means displacement, yes, displacement is given to be 1 meter. Calculate the work done by the force when the displacement is, number 1, in the direction of the force. Now, in the direction of the force means what? It means that the force, if it is in this direction, the displacement is also in this direction. So, if the force and displacement are in the same direction, what will be the angle between them? That's what we need to know. Good. It will be 0. So, here we can write theta is equal to 0. Therefore, work done will be F into S into cos theta. Is the value of G given? Yes. So, if G is given, that means we are expected to convert this kgf to Newton. Now, how do you convert kgf to Newton? You multiply it with the value of G. G has been given to be 10. So, you multiply it with 10. So, it will be 200 Newton. Alright. So, force will be
0.
Sorry?
Work will be 0.
0 what?
Work.
How 0?
Because cos theta is 0.
Yeah.
Oh,
Displace.
my bad.
You're bad only, Zija. Oh. Cos 0. Cos 0 is 1. So 200 into 1 is 200 and cos 0 is 1. So 200 into 1, 200 joules. Joules. Alright. Then question number 2. Question number 2 is saying that when the angle between, the angle of 60 degree with the force. So that means here theta is 60 degree. So let's calculate. So work done will be F into S into cos theta. F is 200, displacement is 1, cos theta is 60. Anyone remembers the value of cos 60? How much is cos 60? Half, right, 1 by 2. Good. So 1 by 2. You can cancel it and you get 100 joules. Then let's see part 3. So part 3, what does it say? Normal to the force. Now who can tell me what does this mean? Normal.
90 degree.
Very good. So what is 90 degree? Theta is 90 degree. So that means work done will be F into S into cos theta, which is 200 into 1 into cos 90. DJ, what is cos 90? Very good. So we know that whenever force is perpendicular to the displacement, work done is 0. So work done will be 0 joules. Yes, good. Question number 5. What's given for question number 5? Read the question. An electric heater of power 3 kilowatt. So that means what's given? Obviously,
The power.
power is given to be 3 kilowatt. Is used for 10 hours. So what is that? Very good. Time is 10 hours. How much energy does it consume? So what is the formula of energy with respect to power and time? Anyone remembers? No one? Well, energy is equal to power into time. So power is 3 kilowatt, time is 10 hours, so it will be 30. Power is kilowatt, so it will be kilowatt, and time is an hour, so it will be kilowatt hour. And that's what we need the unit to be, kilowatt hour. But the second question says that we also have to convert it to joules. Now, how do you convert kilowatt hour to joules? Do you remember? 1 kilowatt hour is how many joules? Anyone? Okay. If you don't remember, it's completely fine. How do you convert it? See, in SI unit, what is the SI unit of power? Is it kilowatt? It's watt. So 1 kilowatt means how many watt? Okay, so 10 to the power 3 watt. And what about time? What is the SI unit of time? Seconds. So how do you convert it to seconds? 60 into 60, right? So if you solve this, what do you get? 6 6 are 36. So 36, then how many zeros? 1, 2, and then from here 3. So into 10 to the power 5 joules. Okay, or in scientific notation, we write 3.6 into 10 to the power 6 joules. So 1 kilowatt hour is 3.6 into 10 to the power 6. That means 30 kilowatt hour will be 30 into 3.6 into 10 to the power 6 joules. So now if you multiply, the decimal will go 3 6 are 18, 8 carry 1, 3 3 is 9, 108 into 10 to the power 6 joules. If you want to write in the scientific notation, the point must be here. Since I'm shifting the point 2 times this way, the power of this will increase by 2. So it will be 10 to the power 8 joules. Question number 6, what does this say? A pump is used to lift 600 kg of water. So basically, let's say here we have water and the pump is used to lift this 600 kg of water. And by what height do we want to lift? We want to lift it by a height of 75 meters in 10 seconds. So time is 10 seconds. Just visual representation of the question. So question number 6 given, mass is equal to 600 kg, depth, that means height, is equal to 75 meter, and time is equal to 10 seconds. Question number A is asking us to find the work done. So what will be the formula of work done in this case? See, we are lifting the water against the force of gravity. So whenever you work against the force of gravity, that is nothing but the potential energy. So work done will be equal to the potential energy. And what is the formula of potential energy? mgh. Good. mgh. So m we already have, g we also have, h it's given, so we can just multiply. So 6 5s are 30, 0 carry 3, 6 7s are 42, 45, then 1 2 3 zeros. So this many joules. Yeah.
So 919 go to MGH, right?
Yes.
But so we are like end up bucket, right? Against the force of gravity.
Yes. Very good. Again, we can write it to be minus. Okay, but here we don't care about the sign. Okay, good, Raghav. Fine. This is easy, right? Second one. Second one, we have to find the power. So what will be the formula of power? Work divided by time. So how much work are we doing? 45000 divided by time is 10 seconds. So everything is in the SI unit. This gets cancelled with this and we end up with 45123, and the SI unit of power is watt. This is easy only. The reason why I'm doing this question is question number C. Okay, this is a little bit technical. Divide by time. Oh. Okay. Now question number C, what are they asking? We have to find the power rating of the pump. This is something that you'll understand better in electricity chapter. But power rating means how much power does the pump take. Okay, whenever you use a machine, right, it takes certain amount of power and it gives back certain amount of power. The power that the machine takes, right, imagine this is the pump. So whatever power that the machine needs to work is known as its power input, or according to this question, power rating. And the power that you get back from the machine is known as your power output. So try to understand. This is the power that the machine is giving in order to lift the water up. Yes or no? This much power is clearly needed to lift 600 kg of water by a height of 75 meter in 10 seconds. Do you agree? So that means this, what do you think this is? Is this the power input or the power output? Output. Very good. Because this is the power that the machine is giving back. You get it? Our job is to find out how much power does the machine need in order to work. Fine. Given that its efficiency is 40%. So how do we use this? So there's a formula for efficiency. This is the symbol of efficiency, eta. It looks like an N with a stretched base. So eta is equal to power output upon power input into 100%. So efficiency is how much are you getting back divided by how much did you give multiplied by 100%. Now if you substitute everything, so this is 40 power output. We know that this is the power that the motor is providing us. So it's 45,000, and power rating means we have to find the power input. After that you just cross multiply, so power input will be this will go down. So 4, 5, 1, 2, 3 into 100 divided by 40. We can cancel this and this as well. 5 zeros are 0, 5 zeros are 0, 5 5s are 25, 5 carry 2, 5 2s are 10, 11, 12, 2 carry 1, 5 2s are 10, 11. I hope I did the calculation right. Please cross verify the number. Is it right? Is right? Okay. So that means how much power does the motor need in order to work? 1,12,500. But how much power are we getting back? Only 45,000. Right? What is the reason? The reason is that its efficiency is very low. 40% is very less for the efficiency. Did you get this? This is tough. Okay. If anyone didn't understand, let me know. I'll explain again. Yes, Raghav. Which part?
Sir, everything. What do you pause just?
I'm sorry?
The for see everything.
Foresee everything. Okay, fine. See, what does efficiency mean? For example, let's say what's your efficiency? If, for example, I give you 10 joules of energy, okay, but you can do only 8. So how much energy have you wasted? 2. So your efficiency will be, you gave back 8 when you took 10. Yes or no? That's your efficiency. Okay, we can define it in terms of power or work done. You got it? Yes or no? If let's say someone like DJ, okay, let's say that DJ, when I give him 10 joules of energy, he brings back or he does 10 joules of work. So what's his efficiency? 1, right? So that means 100%. So it's full efficiency, means he's not wasting any energy. But you, on the other hand, you are wasting some amount of energy, but you are giving back only 80% of the energy back. Are you getting what is efficiency? Yes. So efficiency is nothing but what you get from the machine divided by what you have to give to the machine in order for the machine to work into 100%. After that, what is the power that the machine is producing? Because it's lifting this much of water, so the power that it is giving us is 45,000 and power input. After that is just basic math. You got it? Yes, Elizabeth. You can write efficiency as 1, or you can also write it as 100%. There are two ways of representing efficiency, 1 or 100%. 100% means what? What does percentage mean? Go to your basics, Elizabeth. Percentage means? So if you divide 100 by 100, what do you end up with? Okay. That's question number 7. So what does it say? An ox can apply a maximum force of 1000 Newton. It is taking part in a cart race and is able to pull the cart at a constant speed of 30 meter per second while making its best effort. Calculate the power. So it's very obvious what's given. Right, Mary? What's given? Force. How much is the force? 1000 Newton. And what else is given? Speed. Speed means velocity in this case. So velocity is how much? 30 meters per second. And we need to calculate power. So anyone remembers the formula of power? Remembers, Raghav? Remember? Work by time. Very good. We don't have work. We don't have time. Do we? No. It's a very special formula that I derived in the class, which is in the YouTube video that you guys are ignoring. Very good. F into V. Force into velocity. So force is 1000, velocity is 30. So it'll be 30,000 watt. That's it. That's it. That's it. That's it. Yeah. Done. Do question number 8 on your own. You got? How much you got? What? It's a straightforward. Question number 8. Straightforward. Done. Ananya. Wow. You know what? If you're not able to figure out what this is, no. In physics, you can also look at the unit. What is the unit? Newton. So Newton is what?
So if they ask what speed can like take this velocity of
Yeah, what speed means you have to find the velocity only. Given power is equal to 40 kilowatt. Okay, and we have to find the speed. Force is given to be 20,000 Newton. So see, we'll have to bring it to the SI unit so that we get the velocity also in SI unit. Okay, that's the beauty of SI unit. If you convert everything to SI unit, the answer will also be in SI unit. You don't need to worry about it. Okay, if you start solving right from here, then we know that power is equal to force into velocity, and then power is 40, force is 20,000. That'll be the velocity, and this will be 0 0 and then 4 500. So we get velocity is equal to 1 upon 500. Since you did not use SI unit, the unit of velocity will come from the formula. So what is the formula? Power by force. What is the SI unit of power that we are using here? Sorry, what is the unit of power that we're using here? Kilowatt. And what is the unit of force that we're using here? So your velocity will be kilowatt Newton. Okay, you get it? And then you end up asking questions like this, that sir, how do we convert kilowatt hour by Newton to meter per second? No, Zishan? We don't.
So why?
So we convert this to 40,000 watt. We try to convert everything to SI unit. And if you do that, then you apply the same formula. Power is equal to force into velocity. Power is 40,000 divided by force is 20,000 and velocity. So if you cancel, you end up with 2. So we get velocity is equal to 2. Now, did we write everything in the SI unit? So the answer will also be in SI unit and will be meters per second. You understand, Zishan?
Yes, sir.
This will be too difficult to convert. It will not be, but then we don't do it like that. Question number 12. What does it say? A boy weighing 40 kgf climbs up a stairs of 30 steps, each 20 centimeter high in 4 minutes. So imagine that you have stairs, 20 of them, and there's a boy whose mass is 40 kg. Weight is 40 kgf, means mass is 40 kg. Climbs up a stairs of 30 steps, each of whose height is 20 centimeter in 4 minutes. So for the boy, he does it in 4 minutes. Whereas a girl weighing 30 kgf, right? So we have a girl whose weight is 30 kgf. She does the same thing, but in less time. That is 3 minutes, right? So both of them, they're doing the same task. They are climbing a stairs, 30 stairs in, or each of whose height is 20 centimeter. The girl is doing it in 3 minutes and the boy is doing it in 4 minutes, right? We need to compare their work done. Now, whenever they say compare, right, that means you have to find the ratio. So first let's write down given. Mass of the boy is 40 kg. Then time taken by the boy is 4 minutes. On the other hand, mass of the girl is 30 kg. Time taken by the girl is 3 minutes. And they have given that the height of each stair is 20 centimeter and there are 30 of them. Let's not write that as given. We'll do that mentally. So compare their work done. That means number one, you have to compare the work done means you have to find the ratio. So work done by A divided by work done by B. Now what will be the work done by A? How do we find work done by A? If you're going up, how do you calculate the work done? Yes, mgh. That is mass of the boy. G will remain the same upon h. Divided by, for the boy, oh wait, this is for the girl. Boy, girl. So mass of the girl multiplied by G multiplied by h. Because both of them covers the same height, both of them, for both of them the acceleration due to gravity will be same. The only difference is in height. Oh, mass, sorry. So we can just cancel h and h, g and g, and ma by mg. Sorry, mb by mg. So mass of the boy is 40 upon 30. So we get 4 is to 3. That's the answer. The next thing that you have to find is the ratio of the power developed by them. That means again you have to find power of the boy upon power of the girl. Now what is the formula of power? Work done divided by time. So work done by B divided by time taken by B upon work done by the girl divided by time taken by the girl. So this will be WB by TB into TG divided by WG. If you see this, WB divided by WG, this is something that we have already calculated. WB by WG is nothing but 4 by 3. So we can write 4 by 3. Time taken by the girl is 3 minutes. And time taken by the boy is 4 minutes. So we can just cancel, 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 and we end up with 1 is to 1. Means both of them They have the same power. Change what?
It was WB by DB. How did you change it into W by WG?
I'm sorry? What did I change what? This one, this line. What did I do?
So it was WB by
TB.
that's what I think like
This one, yeah.
so.
Yeah.
So it was WB by DB. So how did you change it to WB by WG?
Okay, no problem. So this is WB by TB into TG by WG. Fine. Now if I just multiply, what do I get? WB into TG divided by WG into TB. Can I write it like this? Instead of this into this, can I write this into this? So what is WB by WG? You got? Will you let me teach, Zishan?
So, because what Newton by kilowatt.
Newton to kilowatt, no?
Newton by kilowatt. 2 seconds.
Yeah, okay. Seconds? Why seconds?
80%.
Yeah, okay, okay, very good. Yeah. Let's see. Let me try to teach. Let me try. Maybe you'll understand something.
Okay, so
Yeah, yeah, yes. Tanisha, nobody is interested in your jacket, please.
Sir, I am.
We are not. Meter per second, yes.
Sir, the meters per second.
Yeah, 2 meter. Oh, yeah. I think when you say it, it's fine. I'm not sure. In reality, we don't use the symbols like that. We don't say meters. It doesn't have a plural word. Plural. 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 See, we are not perfect. Plural. Plural. Yeah, plural. Okay, let's try to. Yeah. Bol, sunega. What? You guys are not allowing me to teach Zishanji. What? Which part? Okay. 1 divided by 2 into 3 divided by 4. Can we write this as 1 divided by 4 into 2 divided by 3 divided by 2? Can I write it like this? In the denominator, what do we have? 2 into 4. Can I rewrite it as 4 into 2? No. What is 2 into 4? What is 4 into 2? So we can.
Have 1 by 2 is 3 by 4, right? So the denominator of 4 and 1. So ultimate denominator is 2, right? But later I teach you 4.
Yeah.
Okay.
We can do that.
So we're changing the numbers, right?
Yes. We are just interchanging the numbers. We can do that.